So welcome everybody to this latest video 162 Maths, and in this video we'll be going over some past GCSE Maths exam questions related to estimation. Now as always, I'll include a copy of the questions that we go through in this video as a downloadable link in the description, and I'll also include links to lessons where I've covered estimation in greater detail with regards to rounding to decimal places, significant figures and estimation as a whole in the description below as well. Now before we get started working through some past exam questions from the topic of estimation, let's just have a quick overview over what it is we need to remember, what it is we need to revise before tackling these questions. Now the key principle to mathematical estimating, and I know some students really struggle to grasp this topic simply because it doesn't quite make much sense, but you want to make sure that when you are estimating numbers that you're rounding numbers to the nearest significant figure or to one sig fig. Now if your skills of rounding to significant figures isn't great, I'll include a link in the description below which goes over how to round numbers up to significant figures in greater detail. Now when the only exception to that is that when you have got a number inside a root, then what you want to do here is you want to round to the nearest square number, because the easiest numbers to root are going to be square numbers. And similarly for cube rooting a number, if you are cube rooting a number, to estimate its value, round that number to the nearest cube number. And again, you need to make yourself familiar with square numbers and with cube numbers to make this topic just a little bit easier for you. So let's have a look at some past exam questions. Now again, if you're wanting a copy of these questions, all you need to do is just simply click on the link in the description. So looking at question 1, it says estimate the answer to 32 times 77.3 all divided by 589. Now again, 32 seems like a number that you don't need to round because it's not decimal, but we need to round that number up regardless. So here 32 to the nearest significant figure, which is a 10, so round this number up to the nearest 10, is going to be 30 multiplied. Now 77.3, the first sig fig is the first 7, which represents 10, so I want to round that number up to the nearest 10, so that becomes 80, and then 589 rounded to the nearest sig fig is going to be to the nearest 100, which is 600. Then from this, 3 times 8 is 24, and I've got 2 zeros, divided by 600. Then from this I can cancel the zeros, so it's just 24 divided by 6, which gives me an answer of 4. Moving on to question 2, it says circle the number that is closest to the value of 120. Well, the nearest square number that's nearest to 120 is 121, and so the square root of 121 is 11. Then moving on to question 3a, it says use approximation to estimate the value. So again here we've got a number that's being square rooted, so we want to round that number up to the nearest square number. So do not round it up to 60, do not round it up to 70. We want to round up to the nearest square number, which is 64. We then want to round 3.92 to the nearest sig fig, so that's going to be 4. So it's root 64, which is 8, divided by 4, which is 2. Then moving on to question 3b, it says is your answer in part A an underestimate or an overestimate? And you need to give your reason why. Well, the answer is going to be that it's an underestimate because the numerator was rounded down and the denominator was rounded up, therefore giving it a smaller answer. Then for question 4, it says use approximation to one sig fig to estimate the value of this. So again, looking at this number here, we're going to round that number up to the nearest sig fig, which is nearest 10, so that's going to be 50 squared, and multiplied by the next number to the nearest sig fig is going to be 0.5, and that's being divided by, and then this number to the nearest square number, which is 100. Now 50 times 50 is going to be 2,500. Then we multiply that by 0.5 over, and then square root of 100 is 10. Then from this, what we then want to do is, anything divided times a half is going to be divided by a half, so that's going to be 1250 divided by 10, and then we just knock the zeros off, giving us an answer of 125. Now again, the key thing to remember with this is whenever you are multiplying by a half is equal to dividing by 2, and dividing by a half is the same as multiplying by 2. So something to make sure that you remember. Then moving on to question 5, it says use approximations to estimate this value here. So again, looking at the three numbers, let me just highlight that. So here we've got 20 times 70 over 0.5. And again, you'd be very tempted to do 24 times 72. But again, you want to round up to one sig fig. Doesn't matter how accurate or inaccurate your answer is going to be. This is mathematically how it's done. So here we've got 2 times 7, which is 14, and we've got 2 zeros. Then here we're dividing by half, and dividing by half is the same as multiplying by 2, so that becomes 2,800. Then moving on to question 6. Again, one sig fig to both these numbers. So here we've got 6 squared divided by 0.2, which then becomes 36 over 0.2. And then from this, what you want to do is to convert this denominator into a whole number. So if we multiply both the numbers by 10, it's just a lot easier. So that becomes 360 over 2, and half of 360 is 180. Then moving on to question 7, it says circle the number that is closest to this value. So here we've got 4 over, and it's going to be 0.02. So again, if I multiply both the top and the bottom by 100, just so that the denominator then becomes a nice whole number, that then becomes 400 divided by 2, which is 200. So it's the third option. Moving on to question 8, it says 925 equals 25 times 37. Circle the number that is closest the value to the square root of 925. Well, the square root of 925 is going to be the square root of 25 times the square root of 37. Square root of 25 is 5, and that is close to, the closest number to 37 is 36, and the square root of 36 is 6, so it's going to be 5 times 6, which is 30, so I need to circle the first option. Moving on to question 9, it says Christine uses a calculator to work out 7.14 squared minus the cube root of 28 divided by 1.95. They get an answer of 49.4224 to 4 decimal places. Is Christine's answer sensible? So let's use estimation first. So 7.14 squared is 7 squared. Then we've got the cube root of, well, the nearest cube number to 28 is 27. And we then round this number up to the nearest sig fig, which is 2. So then what we've got is 49 minus 3 divided by 2. Now using BIDMAS, we've got to do this bit here first. So that's 49 minus 1.5, which gives me an answer of 47.5. Is that close to Christine's answer? Yes, it is. So yes, it's sensible. Then for question 10, it says that a triangular cross-section of a prism is an isosceles right-angled triangle. The volume of the prism is 78.4 cubic centimetres. Use approximation to estimate the value of x. Well, first of all, let's work out the volume formula. So the volume is equal to, well, it's a triangular prism, so it's going to be base times the height divided by 2 multiplied by the length. Now, I know that if I just write the volume on this side, so here I've got x times x, which is x squared, divided by 2, multiplied by the length. Now if I round that number up to 1 sig fig, that becomes 8. And if I round the volume up, that becomes 80. So then from this, if I then take the 8 over the other side, I end up with x squared divided by 2 equals 10. So x squared equals 20. So then x equals the square root of 20. So then looking at this, which square number is closest to 20? Well, it's either going to be root 16 or root 25. this is 4 away, that's 5 away. So the closest answer is going to be root 16, which is 4. Then moving on to question 11, it says here is a triangle. Estimate the area of the triangle. Well, if I round this number up, the angle, it becomes 90 degrees, which therefore means that this triangle, although it doesn't look it, is going to be a right angle triangle. Now to work out the area of a triangle, it's going to be base times the height divided by 2. So then from this, what we've then got is, well, if I round the height and the base, that becomes 10 times 20 divided by 2, which then becomes an answer of 100. Now if you did do 12 times 18, which gives you 108, that's also going to be accepted, but I would say more often than not it's going to be 100 is the answer that you should be looking for. Then for 11b, it says, is your answer in part A an estimate, underestimate or overestimate? Obviously this depends on what answer you've got. In mine it's an overestimate, and the reason for this is because we have used a bigger numerator. So something along those lines would be just. Then moving on to our last question, question 12, it says that a circle has a radius of 5.12 centimeters. Used estimation to work out the approximate area of the triangle. I'm guessing that's supposed to be circle, so let's just change that. So then from this, we know that the area of a circle equals pi times the radius squared. Now if we round pi to 3 and we round the radius to 5, that becomes 3 times 5 squared, which is 75 centimetre square. If you did get that in the exam, I would strongly ask one of the invigilators to make sure that that is correct, but hopefully your exam board filters out any issues like that. Then finally, it then says use your answer in part A to say if whether it's an underestimate or an overestimate, and in this particular case it is an underestimate, and the reason for that is because we have rounded down the radius. And there we go.